In this last section, section number 4, we talk about laws of fractional indices. When the power of an index is no longer a whole number but a fraction, or at least a mixed number, then we talk about fractional indices. Look at this law. A raised to the power 1 over n is equal to the nth root of a, where this n is the same n here. Anyway, how did this come to be? To prove that this is equal to this, we actually turn attention to the meanings of these selected number expressions. The first is 9 to the power 2. Second is 9 to the power 1 over 2. What does each of them mean? That is, what does this 9 mean? And what does this 9 to the power 1 over 2 mean? Please watch out as the meanings of these two number expressions appear shortly. And here they come. First, 9 to the power 2 means let 9 appear 2 times in multiplication to produce a number. Meaning, let 9 start multiplying itself. That is, let 9 start multiplying 9, or multiply 9 by 9, so that in that process, 9 appears 2 times. That will mean 9 times 9. If 3 is what is here, that could have led to 9 times 9 times 9. But because 2 is here, 9 is to appear only 2 times when multiplying itself. What about this one? 9 to the power 1 over 2. You can't interpret this one the same way as this. There is no way 9 can appear half a time when multiplying itself. If we bring this to this, it is no longer feasible. That is, we cannot start writing 9 to appear only half a time in the process. That is practically impossible. Then automatically, this must mean a different thing, not what it means here. What then does this mean? It says, let a number appear 2 times in multiplication to produce this 9. These are the meanings of these expressions. In both expressions, or in both meanings, there is one word that is highlighted, and that one word is number. See it here and see it here. We are doing something with it, and that is why we had to highlight it. This number is the number we get after 9 multiplies itself and appears 2 times in the process. But in this number, it is a number which multiplies itself a number of times, that is 2 times, to give us 9. Again, this number is the number we get when 9 multiplies itself, appearing twice. But here, the number is that number which, if it multiplies itself and appears twice, the result is 9. In this statement of A, what then is that number? And in this statement of B, what then is that number? Let's find out. Here we go. It says, in A, that is in this, the number, that is this number we referred to, is equal to 81. Do you agree? You should, because 9 times 9, in it appears 2 times. That is, in 9 times 9, 9 appears 2 times, and 9 times 9 is equal to 81. So the number spoken of here is 81. But in B, the number is 3. Why? What is that number which appears 2 times in multiplying itself to produce 9? Is it not 3? Therefore, in this statement number B, the number we are talking about is 3. Therefore, 9 to the power 2, that is this 9 to the power 2 is equal to 81. And this 9 to the power 1 over 2 is equal to 3. Now, notice that the expression 9 to 1 over 2 is equivalent to square root of 9, or just like this. It means that these two, since it is simplest of all the roots, could be absent, and yet we know it is there in principle, meaning that this sign and this sign are the same thing. If we begin to have something like cube root, fourth root, fifth root, and other higher roots, we do not choose to ignore the number which is here. But because square root is the smallest of all the roots, we can choose to ignore it. And here we have chosen to ignore it. It means that this expression and this expression are the same thing. So if you want to write square root, it is either like this with 2 here, or just this sign without anything. Alright, so we now understand that this and this are equivalent. It means that the two of them have equal values. That is, this and this have equal value. What do we mean? What we mean is that both of them produce the same result when interpreted. Don't forget how we gave this one interpretation. This one too, earlier in a different topic, was given an interpretation. Now we realize that when this is interpreted and this is interpreted, both have the same result or the same answer. And what is the answer? 9 to the power 1 over 2 when interpreted gave us 3, and again square root of 9 when interpreted also gave us this 3. The difference is just that here this is either plus or minus. Even here this is also plus or minus. Therefore both are equivalent in every case. Therefore, since 9 to the power 1 over 2 is equal to 3 and square root of 9 is equal to 3, it means that 9 to the power half is equal to square root of 9. It means that the value of this is equal to the value of this. If you use other constants of your choice to test out, you will find out that this statement is valid. Then, until then, let me assure you that in line with this observation, in general, a to the power 1 over n is equal to nth root of a. If what is here is 2, then what I'm going to have is square root of that number a. If what is here is 3, then I'm going to have the cube root of that number. If what we have here is 4, what I'm going to have there is the fourth root of that number. If what we have here is 5, what I'm going to have is the fifth root of that number, and in that order. Let's now see some examples that conform to this law. And here come about 4 examples. The first one says 64 raised to the power 1 over 2. Based on this law, it is equal to square root of 64. Don't forget that we can choose to ignore this 2, and we know it is still there. Square root of 64 simply means which number appears 2 times when multiplying itself to give 64. The answer is 8. Number B, 8 raised to the power 1 over 3 is equal to the cube root of 8. We can't choose to ignore these 3. It is not the simplest root. Therefore, we have to write it. Cube root of 8 is equal to 2. Why? It is because cube root of 8 means what number appears 3 times when multiplying itself to give us 8? It is 2. Why? 2 appears 3 times when multiplying itself to give us 8. Check it then. 2 times 2 times 2. It appears 3 times when multiplying itself, and the result is equal to 8. Therefore, the cube root of this 8 is equal to 2. I just hope you are following what I'm saying. The third one is 49 raised to the power 1 over 2. It is equal to the root square root of 49. Here, I have chosen to ignore these 2. Don't forget that in the first case, the 2 wasn't ignored, but here it is ignored. Highlighting the importance of the fact that we can choose to ignore the 2 or write it. Here, square root of 49 is equal to 7, meaning what number appears 2 times? Don't forget that 2 is here. Which number appears 2 times when multiplying itself to give us 49? The answer is 7. Why? Let 7 multiply itself. How many times will 7 appear when multiplying itself and the result is 49? It's just 2 times. How? 7 times 7. In that expression, it appears only 2 times and the result is 49. Therefore, the square root of 49 is equal to 7. Next, that is number D, 32 raised to the power 0.2. This is the first time we have seen a decimal fraction as a power. That will not be a problem. If you want to conform to this law, all you should do is to convert this 0.2 to a vulgar fraction. This is a vulgar fraction as a power. This is also a vulgar fraction as a power. The same applicable to what you have here, but this place will have decimal fraction as a power. To conform to this, which is actually a fraction, a vulgar fraction, we have to convert this 0.2 to a vulgar fraction. This is it, 2 over 10. And when brought to the lowest term, we have it as 1 over 5. It therefore means that this expression and this are the same thing. And when solved or evaluated against this law or with this law, we have it that the fifth root of 32 is equal to 2. What do we mean? And what does this mean? It means which number appears 5 times when multiplying itself to give us 32? The answer is 2. Check it, please. Let 2 keep on multiplying itself. When it appears 5 times, what is the result? The result is 32. Therefore, the fifth root of 32 is equal to 2. All right, at this point, find out if you can tackle what follows after you have heard that a to the power 1 over n is equal to the nth root of a. And here comes a checkpoint. It says, evaluate the following operations given that a to the power 1 over n is equal to the nth root of a. The first is 36 raised to the power 1 over 2. The second one, that's number B, is 64 raised to the power 0.25. The third one, that is C, is 125 raised to the power 1 over 3. The last one, and that is D, is 243 to the power 0.2. Let's see another law that is connected with this law of fractional indices. And here comes that second law, which likely is going to be the last law in the list of laws of indices. And it says, a raised to the power m over n is equal to the nth root of a, all to the power m. How do we know that this is valid? Let us reason. First, we recall that a to the power 1 over n, shortly proved, is equal to nth root of a. Therefore, a to the power m over n is equal to first a to the power 1 over n all to the power m. I hope you know how this became this, especially how this bracket came to isolate this a to the power 1 over n. If you have forgotten, please make reference to this law. You will recall that a to the power x all to the power y will give us a to the power xy. What it means is that this times this will still give us this m over this n. Please confirm that this times this, that is this x times this y, is xy. Likewise, 1 over n times m will give us m over n. I believe that you learned that when you learned the formula for multiplying fractions. Okay, if we have confirmed and we have remembered that 1 over n is equal to 1 over n times m is equal to m over n. Let's proceed. We now recall that a to the power 1 over n, this which is equal to what we have here, has already had its own meaning before this point. The meaning it had, based on the first law we had just a short while ago, is nth root of a. It means that this alone has its own meaning. Its meaning is this. The two are interchangeable. What it means is that this can replace this, and this can replace this where necessary. In this case, we want to replace this with this. That is why we say, now if we replace a to the power 1 over n by nth root of a, everywhere it appears, what we have is what? That a to the power n, m over n, see it here, is equal to, see it's equal to here. Now, a to the power 1 over n, all to the power m, which means that the same a to the power m over n, which is here, is equal to, now, time has come for us to replace this 1 over 1, 1 raised to the power 1 over n, by what it stands for. Is this not this? Yes, it is. Is this not equal to this? It is. What it means is that this can replace this. That means we can push away this, whatever it appears, and write this in its place. Now, this appears here. We want to push it away and take this to replace it. Look at where it has happened. This a to the power 1 over n no longer is here. It is now this that has come to replace it, since the two are equal. But the m, which is the power, has remained unchanged. Therefore, a to the power m over n is equal to the nth root of a, all to the power m. The same thing as what we saw at the outset of this subsection. Let's now see some examples that conform to this law. And here come about 3 examples. The first one says 16 to the power 3 over 2, based on this law, is equal to the square root of 16 all to the power 3. Our a is this 16, our m is this 3, our n is this 2. Check where this n is. See it here. That means that this 2 will be here. Check where this 3, this m is. It is here. That means that this m being 3 is here. And this 16 is the a, and it is here. So in the end, it means square root of 16. Whatever you get as the value of square root of 16, raise it to the power 3. And so what is the square root of 16? It is 4. Then to the power 3, see it here. 4 to the power 3 does not mean 4 times 3. It means 4 times 4 times 4. And if you do that, the answer is equal to 64. Therefore, this is equal to this. Next, that is number B, says 243 raised to the power 0.4. Again, we're experiencing a power in form of a decimal fraction. The first we have to do is to convert this 0.4 to a vulgar fraction. Let's do it. It will be equal to 4/10. Perhaps we learned it at the time we learned about fractions, different kinds of fractions, and how to convert one type to another. 4/10 is the vulgar fraction, and we can convert it to its lowest term, and it is equal to 2/5. I just believe that you know how 4/10 became 2/5. In any case, 243 to the power 0.4 is the same thing as 243 to the power 2/5. Again, using this law to evaluate this, we have it the fifth root of 243 all to the power 2. What is the fifth root of 243? It simply means what number keeps multiplying itself and appears 5 times to give us 243. The answer is 3. Why? If you multiply 3 by itself, when it appears 5 times, the result will become 243. Please confirm. Because of that, we have 3 to the power 2. The 2 have been here, and 3 came out of this fifth root of 243. Then 3 to the power 2 is equal to 9. 3 to the power 2 is not 6. 3 to the power 2 is not 3 times 2. It means 3 times 3. So the answer is equal to 9. The last example says 4 to the power 2.5. This is a mixed number. It contains both a whole number and decimal fraction. But we can still convert this to a vulgar structure. That is to say, structure of a vulgar fraction. Something over something is what we want to have, not something point something. So 4 to the power 2.5 will be equal to 4 to the power 25/10. Please reduce this to its lowest and don't convert it back to decimal or that point, any number. That will give us 5/2. How? When 5 divides this, we have it 5. When 5 divides this, we have it as this 2. Therefore, 4 to the power 2.5 is the same thing as 4 to the power 5/2. Then, applying this law, this is what we have. It is square root of this 4 all to the power of this 5. First, what is the square root of this 4? It is 2. I hope you know why it is 2. By now you must have known. Then to the power of this 5, 2 to the power 5 is equal to what? 32. 2 to the power 5 is not 10. That is because 2 to the power 5 is not 2 times 5. It means 2 times 2 times 2 times 2 times 2. That is, let 2 multiply itself and appear 5 times in the process. The answer is equal to what? 32. At this point, look out for an exercise. And this is checkpoint. It says evaluate the following operations given that a to the power m/n is equal to the nth root of a all to the power m. The first one says 81 raised to the power 3/2. That's number A. And number B says 49 raised to the power 1.5. Number C says 27 raised to the power 4/3. The last one, and that's number D, is 64 raised to the power 5/6. So far, so good. Let us now see a summary of the laws of indices, cutting across all the laws, subsections that we have. The first, a lot of multiplication of indices and derivatives, and a lot of division of indices and derivatives, and a lot of fractional indices. Let us have a summary of all the laws taken across these sections.